Hi everyone, this video is going to be on density, how to calculate it, and problems that you'll definitely come across when taking general chemistry in college. So density is always represented with a lowercase d, and it's calculated with mass over volume. And the two units that are usually used are kilograms over meters cubed or grams over centimeters cubed. And something that you need to know that is very important is that centimeters cubed is equal to milliliters. So if you have units of grams over centimeters cubed or grams over milliliters, those are exactly the same. And an easy way to remember the formula for density is to have density equals, and you can draw a heart and just put your division sign right there. This looks like an M and this looks like a V. So density is always mass over volume. So that's an easy way to remember the formula for density. Let's get into a problem that you'll see in your general chemistry classes. So this question reads, calculate the mass of a lead sample which has the density of 3.178 grams per centimeter cubed and displaces 34.7 milliliters of water. So we have our formula, density equals mass over volume. So one way to approach this problem is to just strictly stick to the formula. We know what the density is, we can plug that in, 3.178 grams per centimeter cubed. And we know what the volume is that it displaces, which is right here, 34.7 milliliters. And we're left with mass, which we can calculate. So if we just multiply these two numbers together, we can get the mass in grams, which if we plug that into our calculator, we're going to get 1.10 times 10 to the second grams. So that's what we have for our mass. But the way I personally like to do it, and which I think is a better way because you'll use this method more during general chemistry, is to use stoichiometry. So we can start with the volume that the lead sample displaces, which is 34.7 milliliters. And we want to get to mass. So we have the density here, which has a unit of mass right here, which is grams. So we can use that to get to the mass. But we want to convert milliliters to centimeters. You don't have to because they're equal, but to make it easier for yourself to see where the units are coming from, you can do that. So if we have 34.7 milliliters, we know that 1 milliliter is equal to 1 centimeter cubed. Milliliters will cancel out. You're left with centimeters cubed. And now we have centimeters cubed right here. So we have 1 centimeter cubed with 3.178 grams. Centimeters cubed cancel out. The milliliters canceled out. And what we're left with is grams. So if you plug that into our calculator, 34.7 times 3.178 equals 110.2766 grams. We want to stick with our significant figures, which is 3 right here since we're multiplying. So we can put this into scientific notation, which will be exactly the same as the answer that we got here. 1.10 times 10 to the second grams of lead. Another problem, and it's a common exam problem, is to test to see if the grams that you have and the volume that you have matches with the true density of an element. So this question reads, a man buys a gold engagement ring that weighs 2.34 grams. The woman wants to determine if the ring is pure gold, so she displaces it in a graduated cylinder and finds that it displaces 4.25 milliliters of water. Determine if the ring is pure gold, knowing the density of pure gold is 19.3 grams per centimeter cubed. So, what we're given is the grams of the ring, so we can see that mass is 2.34 grams. We know that it displaces 4.25 milliliters of water, so the volume there is 4.25 milliliters. We can easily now calculate the density of this particular ring. So we know density is mass over volume, so our mass here is 2.34 grams over 4.25 milliliters. Using our calculator, we can calculate the density. 2.34 divided by 4.25, that's 0.55 grams of the supposedly gold ring. So what we need to do now is compare the density that we calculated against the actual density of gold. And to do this problem, you need to be given the actual density of gold. Otherwise, there's no way of you to know what, if this is really gold or not. So you have this density, which is calculated, of the actual ring. You know the actual density of pure gold is 19.3 grams per centimeter cubed. These two numbers are no way near each other at all. If this number was 19.1, 19.0, somewhere around 19, we could say that yes, this probably is pure gold, but we have 0.550 against 19.3. Chances are this is not real gold. So we can say no. The ring is not pure gold because the densities don't match up.